Humans across the world currently use approximately 18 terawatts of energy each year. Plants provide nearly a third of this demand, while fossil fuels provide almost two-thirds. With predictions that oil and gas will become extinct in 40 to 60 years, where coal may continue to exist for another 130 years or so, these are finite resources that will need to be replaced with renewable alternatives. Besides the fact that we are running out of these resources, the emissions generated by processing these fuels contribute to as much as 90% of global warming. Nuclear energy is currently our leading renewable resource. However, problems associated with it have led us toward researching safer and more efficient technologies. Conditions on Earth offer wealth and variety of energy potentials waiting to be developed and utilized in a clean and responsible way. The key is to harvest these resources in geographic locations where the climate conditions are ideal, while improving our harvesting techniques.
According to the U.S. Energy Information Administration, energy associated with the manufacturing and operation of buildings currently makes up nearly half of all energy consumed, with transportation and industry accounting for the other half. Therefore, if we can decrease the amount of energy associated with buildings by designing them to be efficient and self-sustaining, we will drastically reduce the total annual consumption of energy.
Net zero design is building that produces at least as much energy in the water as it uses of the course of the year. A well-designed net zero building can be totally independent from the electricity and water grid supply. Currently, the net zero concept can regards to the building is to be defined three different ways. The first one is energy can usually be harvested through a combination of energy-producing technologies. The second one is the overall use of energy can be reduced with extremely efficient natural ventilation system and natural lighting technologies. The third one is the self-sufficient water system, including rainwater harvesting, greywater reclamation, and wastewater treatment will help reduce water consumption and minimize water contamination.
Solar technology continuously advanced to become an affordable key to create self-sustainable systems. One of the most common types of using solar energy is photovoltaic system, which is used to convert sunlight into electricity. Another type of solar energy system is the solar water heating system, which is designed to heat water by sunlight. The solar voltaic system and the solar water heating system are safe, reliable, low-maintenance source of solar electricity that produce no pollution or emissions. They can be ground-mounted, installed on building rooftops, or designed into building materials. The only concern is that panels should be oriented between southeast and southwest for the best performance. Geothermal power utilized stored energy below the Earth's surface. Temperature under the frost line maintained between 10 Celsius to 16 Celsius, remaining warmer than the air above it in the winter and cooler in the summer. A geo-exchange system takes advantage of this constant temperature by transferring heat stored in the earth into a building during the winter and transferring it out of the building and back into the ground during the summer. Besides solar energy and geoenergy, there are lots of other renewable energy resources, including wind power, hydroelectrical power, tidal power, and biomass.
The first step to affordably producing as much energy as your building consumes is lowering the amount of energy it takes to keep your building comfortable. Maintaining the right interior temperature, humidity, and air quality often accounts for 30% or more of a building's energy use. But you can do this passively, without demanding purchased energy at all.
In some part of the country where temperature and humidity level permit, natural ventilation through operable windows can be very effective and energy efficient way to supplement HVAC systems. Natural ventilation also provides outside air ventilation, cooling, and thermal comfort when conditions permit. Daylighting is the control of natural light, which includes direct sunlight and skylight, into a building to reduce electric lighting and saving energy. By providing an outdoor illumination, daylighting helps create a visually motivating and positive environment for building residents or users. This reduces as much as the total building energy costs.
Good quality water is a diminishing source. People must generate a healthy relationship with water if they want to survive and protect the biodiversity of the planet through a sustainable design and regulation. One of the concerns is that the potable water is often used for a lower quality purpose, such as the toilet flushing, irrigation, and the laundry. Research shows that the majority of water is consumed only one time pass without any attempt of reusing it. Net zero water is a similar concept to a net zero energy. Through a combination of rainfall harvesting, aggressive conservation, and a water recycling, building can achieve a self-sufficiency from a water grid. The primary goal of this practice is to use resources more efficiently and reduce a building's negative impact on the environment.
toward Net Zero Water, Best Management Practices, which describes the integration of closed-loop systems with a focus on rainwater harvesting, graywater reclamation, and on-site wastewater treatment, including composting toilets. Case studies illustrate best-in-class examples of innovative water systems used by actual projects from around the globe.
All our water in SERS comes from the rain, and the water leaving the building is better quality than the rainwater landing on the roof. So the effect of SERS is actually to improve the quality of the water flowing through our site. That makes us net positive in water quality.
We will use the recently completed Portland Community College Newburgh campus, designed by Henneberry Eddy Architects, as an existing example of how to achieve a net zero energy building in our climate.
This building has been designed to use about 1/6 of that of other similar buildings in use today. The design of this building begins with a super-insulated envelope consisting of efficient low-emissive windows and extensive use of interior concrete mass in floors and walls to absorb and stabilize building temperatures. A natural ventilation system includes a night flush cool-down process that allows cool air in, aided by wind-powered turbines that draw warm air up and out through the ventilation stacks. A passive daylight system maximizes natural indirect sunlight with skylights called clouds that diffuse and distribute daylight to reduce or eliminate the need for electric lighting. Ceiling fans are used as needed to circulate air to maintain comfort levels. The key to the building's net zero capability is the 7,000 square foot rooftop solar panel array powering the smart mechanical systems. 20% of the array consists of translucent panels that overhang the building's entrance and can be observed from underneath. The solar panel array provides energy for all the building's electrical needs, including a heat pump system that is 4 times more efficient than traditional electric heating in the Northwest. The heat pump circulates water at 90 degrees Fahrenheit through pipes embedded in the exposed concrete slab. Under these combined systems, all mechanical cooling is eliminated and very little heating is needed. Infrastructure for a stormwater disposal system is in place. The landscape design emphasizes the use of native plants and a high-efficiency irrigation system to achieve low-water landscaping.
The field net zero building is really exciting stage right now. We think that regenerated sustainability as mean our buildings that actually make things better. And by that, we mean both make environmental conditions better and improve environmental conditions, but also human well-being. We like to see every building on the planet to design this way. Thank you very much.